Okay. Uh, CAN stands for Controller Area Network. It is known as CAN bus protocol. It is a robust vehicle bus standard designed to allow microcontrollers and devices to communicate with each other in applications without a host computer. CAN was developed by Robert Bosch in 1986 for automotive industry. It is optimized for sending small amounts of data between multiple nodes. It is basically a two-wired half-duplex high-speed serial network technology. It is basically used in communication among different devices in low radius regions such as the automobile. It provides a data rate of 125 kilobits per second to 1 megabits per second, and this data rate is provided for around 2048 different message identifiers. CAN allows multiple devices to connect to each other. Let us see the CAN diagram. As we can see in the diagram, it allows number of nodes to connect to each other on a single bus, as shown in the figure. Each CAN node may operate as a transmitter or a receiver at any time. Rather than sending in data to a specified target, data messages are broadcasted to all the nodes on each bus. Each receiver node decides for itself if the data is relevant by looking at the message frames identifier, which describe the content of the message. A message identifier also represent the priority and allows for the automatic arbitration when multiple nodes try to transmit at the same time. Originally, the ISO standard laid out for standard CAN protocol is 11-bit identifier, which means it will contain 2 to 11, that is 2048 different messages. CAN can be extended to a 29-bit ID, resulting in a 2 to 29 identifier, resulting in 2 to 29 identifiers. Now, let us see the CAN frame format. Uh, CAN uses different signal with two logic states called recessive and dominant. Recessive indicates that the differential voltage is less than a minimum threshold voltage. Dominant indicates that the differential voltage is greater than the minimum threshold voltage. Interestingly, the dominant state is achieved by driving a logic 0 onto the bus, while the recessive state is achieved by driving a logic 1. Let us start with the standard CAN frame. The first bit is the start of frame. It is mostly a dominant bit. The second bit is a 11-bit identifier which establishes the priority of the CAN message. The smaller the identifier, the higher the priority of the message. The third one is RTR, which is also known as remote transmission request. This bit is normally dominant, but it goes recessive when one node is requesting data from another. The next one is identifier extension. This bit is dominant when a standard CAN frame is being sent and not extended. The next one is DLC, which means data length code. This frame signifies how many bytes of data are in the message. And after that, the data blocks. There's a data block which contains the data itself, being as many bytes as represented in the DLC bits. The next block is CRC, which is the cyclic redundancy check. It is a 16-bit checksum for detecting errors in the transmitted data. Then the acknowledgement block comes. If a message is properly received, the receiving node overrides the recessive acknowledgement bit with a dominant bit. Next frame is end of frame. Signifies the end of the CAN message and is 7-bit wide for detecting bit stuffing errors. The last frame of the CAN protocol is interframe space. It is used to introduce time delay. Thank you.